All right. Page 1, question 1. All right, first thing they give you is 30x to the 4th minus 48x to the 2nd plus 15x, right? And so we're told to factor completely. Well, the first step on any problem that you want to factor is to try to take out your greatest common factor, okay? And that's just any number that can divide any of these numbers, right? So if we think about it long and hard, we might just say, you know what, 3 can divide all those numbers, right? And then we look at our variables and say, what's the most number of variables that I can take out, okay? And I can only take out one of these, right? Because I'm limited by the smallest one, right? So I can take out 1x. I can't take out more than that because that one only has 1. So we're going to take out an x from each one of these. And so then we just divide each one by that greatest common factor that we found. So 30 divided by 3 is 10. And then we took away one of the x's, right? So this is going to be x to the 3rd. And so we do the same thing on this one. We do negative 48 divided by 3, which is 16. We took away one of the x's here, so we're just left with an x. And then we did 15 divided by 3, which is 5. And then we took away the x on it, so that simplifies it down to this. And we look at it, and we can try, but there's really nothing more we can do with this. So this one is completely factored. Number 2. We got 2xy plus 2x minus 10y minus 10. Now one neat thing we can do with these is we can actually separate these into this group, right? And then into this group when we factor, okay? And so let's factor out what we can out of this group, okay? What this does, we can factor out a 2 out of that group and an x, right? And so the only thing we have left behind on this one, we took away the 2, we took away the x, so it's just left with a y. Now this one, we took away the 2x, the only 2x that was there, so there's really nothing. But we don't put a 0, we still need a placeholder. The reason why we do this is because if we redistribute this back out, we get a 2xy here, and then we get a 2x here, which would recreate what we just did, okay? Now, this isn't going to get butt up with another expression because that would mean multiplications going on, and we only multiply these. So we're going to have a plus or a minus here. So let's do a minus since these are both negatives. In fact, we're going to take out a negative 10 from these. That's our greatest common factor between these two. So once again, we can factor this out. The only thing left behind here is a y, right? And it's a positive one because we took away the negative 10. And then on this one, we're doing a negative 10 divided by a negative 10. And that just leaves us with a 1. Same thing kind of happened with this that happened with this, right? And now we got matching expressions. Okay, and what we can do is we can factor those out just like we did the other one. So r plus 1 comes out of both of these, and so this is just left behind. So the thing on the outside of these parentheses gets put in its own parentheses to 2x minus 10. If we refactored all this back out and did our full method, we'd end up with this thing that we started with. So we just did it in reverse. Okay, number 3. We get y squared minus 18 y plus 80, right? And so we can just split these out into linear factors. A lot of professors will go around it the long way, but really what we're doing is we're trying to find out what multiplies to do this to give you that number, 80, right? And then what adds We might even be subtracting, but when we combine our numbers, we're looking for a negative 18, whether it's subtraction or addition. On this one, we know, though, that if we're getting a positive product and we got a negative sum, that both of these are going to be negative. Okay? So we know that a negative 1 and a negative 80 multiplies to be 80, but that doesn't work. We keep on going down our list, and we keep looking for this thing. And we're not finding it until we get to here, right? And now we found it right here. So we got a negative 8 and a negative 10 that can be 80, and a negative 8 and a negative 10 that can add together to be negative 18. So this thing is just going to split out into two linear factors. It's not equal to anything just yet. It's just an expression, but this thing can split into y minus 8 and y minus 10. Okay. Maybe on one of these I'll get to show you the long way of doing this, but I don't want you to overwhelm yourself. That's just the fastest and easiest way to do it, is just setting those y's minus 8 and y minus 10. Okay, so question 4 is 2n squared plus 10n plus 8. Okay. Now what we can do on this is we can divide or take out our greatest common factor on this one. So we can take out a 2. Right? We can divide all these numbers by 2. 2 divided by 2, that just takes away our 2, and we just get an n squared left. 10 divided by 2 is 5, so we get a 5n, and then 8 divided by 2 is 4. Okay? And now we're down to these, and we don't have a lead coefficient, so I can do this the same way as I did this one. That's kind of our qualifier to just jump straight to our linear factors. But our 2 is going to be on the outside, and then this one splits into numbers that are multiplied to be 4, right, and add to be 5. Well, we know these are both going to be pluses to give us a positive result and a positive product, or positive sum and a positive product. But we got 1 and 4, and we found it already. Once we add those, we get 5, and we multiply them, we get 4. So this is going to be a 1 and a 4 here. And we lead with n's. And we can recreate this n squared. Okay? And that's our final answer for that one. Number 5. We get 5h to the 4th minus 20 h to the 3rd plus 15 h squared. Okay, so first thing we do, look just like we did on this one, we try to take out a greatest common factor. We would have tried to take one out on number 3, but that one didn't have anything. On this one, we can divide each one of these numbers by 5. Okay? And not just a 5, but we can take out an h as well. Right? In fact, we can take out 2 of them. That's our smallest amount. So we want to take out our smallest amount of h's. So what we have left over after we take out our 5h squared on this is just a h squared left over. Right? We just took away 2 of them, so 2 of them's left. So negative 20 divided by 5 is negative 4. We're going to take away our 2 h's again, so we just get 1 h left over. But here, 15 divided by 5 is 3, plus 3, and we took away all of our h's. So that's what we have left here. Now once again, we try to see if we can't split these out again, and we don't have a lead coefficient again, so sorry for y'all, I'm not going to do it the long way, but I think on this one we're going to get to do it. There. Alright. So these split into just, and this is a negative here. We're going to need a negative on both of our things, and we found it already again. Negative 3 and a negative 1 multiply to give you a positive 3, and they add together to give you a negative 4. So this is going to split into h minus 1 and h minus 3. And we just want to bring down our 5h squared to be a part of those two as well. Okay? Let's start with number 6 here. Okay. Alright, we get 2y squared plus 5y plus 3. Okay? So first we try to take out a greatest common factor, and that doesn't happen, right? We don't have anything we can divide each one of these numbers by. But we have a lead coefficient now. Now when we have a lead coefficient that's other than just 1, if it's 2 or greater, we want to take this number and we want to multiply it times that constant, right? And that's going to be our number that we're looking for now. So 2 times 3 is 6, right? And we're still looking for things that add to be our middle term, right? And now we know that 1 and 6 multiplies to give us 6, but that doesn't add together to be 5. Okay? That adds together to be 7. And then we got 2 and 3. And we found it already. We know that 2 and 3 add to be 5 now. So what we do is these two numbers are going to stay the same, but this number is going to split into these. And what happens is this 2y squared comes down just like it was here. And then this 5 is going to split into a 2y and a 3y. Okay? And then we just bring down our constant just like we did with our front number. Okay? And now it's back to what we did in problem number 2. Okay? So we're going to split these and factor these out separate. Okay? Now we know that we got a 2y that can come out of both these. So that's going to be our greatest common factor for those. And now what's left behind is just we took out a 2, we took out one of the y's, so just a y is left behind. And then we took out every bit of this one, and we still need that 1 that's going to be our placeholder. That way when we multiply, we end up getting that same thing again. Now on this one, our greatest common factor is 3. And we took away the 3, so a y is left behind. We took away the 3. 3 divided by 3 is a 1. Okay, once again, these two are in common. We can take that out, y plus 1. And then we just write down what's on the outside of our parentheses, that 2y plus 3. And that's what this factors into. That's the long way of doing it. You can do it just the same on one of these shorter ones that we had up in 5, 4, and 3. But there's no need to go about it this long way unless you just like playing with numbers like that. Alright, number 7. We got 2s to the second plus 11s minus 21. Okay? Now in this one, it says factor the trinomial completed by using any method. Remember to look for a common factor first. Okay? And we don't have a greatest common factor, so we're going to multiply this times this. So 2 times negative 21 is going to give me a negative 42. Okay? Let's look what we get when we do these, right? So we know 1 and 21 gives me, now I know I'm looking for a positive sum right here, so our bigger number is going to need to be the positive. Our smaller number needs to be the negative to give us a negative product. Oh, I'm sorry, 1 and 42. I'm sorry. And our next one is 21, but it's negative 2 and 21. Let's keep going down the list until we find something that adds to give us 3. And what is that? 14, right? And then, what, negative, we found it already. It is that one. I'm about to look for more numbers, but we found our answer as far as what this is going to split into, because that adds to be 11. Alright, so once again we do what we did on number 6. We split these ends. It's going to be 2s squared, and then this splits into a negative 3s, and then a positive 14s, and minus 21. So once again we look at these two together, and then these two together. Alright, the only thing that comes out of this, no numbers come out, but just an s on this one. And so our 2, we took away one of the s's, so we still got an s left there. Right, and then we have our minus, and then we took away this s, and so we just have a 3 that's left there. Right? Now in this one we can take out a 7, right? So plus 7, I'm going to put here. And so 14s divided by 7 is a 2s. And then a negative 21 divided by 7 is a negative 3. And once again, we got matching expressions again. So that can come out as 2s minus 3. And then we write what's left behind outside of ours, and that's s plus 7. Okay? Number 8. This is 12n squared minus 5n minus 3. Okay? Alright, so once again we're going to multiply our back. Actually, we look for our greatest common factor first. Don't forget that. Okay? But we can't do that, right? Nothing comes out, so we just multiply the 12 times the negative 3, which gives us a negative 36, right? So we go down our list. We know we're going to end up with a negative, so our bigger number is going to be negative on this one. So 1 and negative 36 gives us that, but doesn't add to that. 2 and negative 18. 3 and negative 12. We're getting closer. 4 and negative 9, and we found what we're looking for. Okay, so this splits into 12n squared, and we'll do a plus 4n, and then minus 9n, and then minus 3. Right? These two just stayed what they were. Let's split into those two. If we combine these back together, we'd still get our negative 5n. Alright, so we look at these two, and we look at these two, and we're going to take our greatest common factor again. So we can take out 4 out of both these, and an n. Right? And so what's left over is a 12 divided by 4 is 3. And then we took out one of the n's, so one's left behind. And then we took out everything on that one. So this is just plus 1. We need that placeholder. It would recreate it if we multiplied it. And now when we got both negatives, I like to take out a negative. Right? And then so our greatest common factor here is 3. Right? And so negative 9n divided by negative 3 is a positive 3n. Right? And then negative 3 divided by negative 3 is a 1. It seems like they like doing this to us. Huh? So this is our greatest common factor that comes out, right? This expression, and so we write our numbers that are left behind in its own parentheses again. So 4n minus 3. Okay. Number 9. So we got 49c squared plus 28c plus 4. And I thought we were going to be able to divide out of 7, but that 4 is going to keep us from doing it. So we can't take out a greatest common factor on here at all. So what we're going to have to do is multiply this times this, and it's starting to get bigger and bigger, ain't it? So if we multiply 4 times 49, we get, what? I think it's 196. Let me just double check my mental math. It is 196. Let's list out these factors of it, right? Whew, this is tough. Alright, so we got 1 and 196. And really, one thing I do too, it's just my little cheat method that I'm going to show you, is I take my 196, and you might not follow this, but I split it out. I know that I multiplied 49 and 4 to come up with this. I know this splits into 7 and 7, and this splits into 2 and 2. And what we're going to find is that any numbers we come up with is going to be a combination of these 4 numbers, right? Well, and if we had 1, right? So this one is 1, and this whole 196. But then I'm going to do 2. And then do the numbers that are left over, right? I don't have to do the 1, but 7 times 7 times 2 is 98, right? And then I can do 4, right? And that 49. That still doesn't get us what we're looking for, right? And then we can do the 7 and this 2. We can do the 14. So 14 times 14, that's the other one that we can look for instead of multiplying every number that we come across. But now we found it, right? This is 14 and 14. So we can split this into 49c squared plus 14c plus 14c plus 4, right? And now we're ready to go. Alright, so we're going to be taking out a greatest common factor here, right? And that is 7, right? And a c, right? And so we divide this out. 49 divided by 7 is 7. Take out our c. And over here, 14c divided by 7c is 2, plus 2. And over here we can take out a 2, right? 2, no letters, right? And so 14c divided by 2 is 7c, and then 4 divided by 2 is just 2. Once again, we got matching expressions, so that can come out. 7c plus 2, and then 7c plus 2. Okay? And I'm going to show you a different thing that we could have done to this. If you recognize this, and I'm going to be honest, I didn't on this one, but let's look at this one more time. Look at number 9 one more time. This is actually one of those special factors. And when I'm smart enough and looking for it, I can recognize it. Now, I know that this can be perfectly square rooted, right? This can be perfectly square rooted into a 7c. If I did 7c times 7c, I'm going to get 49c. And on the back end, I know that that's a perfect square, right? And if I square root that, I end up with a 2, right? What I really do with this symbol is I just borrow the symbol from this. The middle term always has that same symbol that we're looking for if this is going to work, okay? And this might just turn into this, right? And so the only thing I have to do to check it is multiply these two by each other and then double it, and if it equals that, then that's what it is. Well, 7c times 4 is, hang on, is 28c, No, I'm sorry. That's what we're on. The square root of 4 is 2. So we do 7c times 2, which is 14c, and then we double it, and that's 28c. So it does work out for this one. We know that it works out for this one, and it works out for this one. So this would be our answer. That's the fast way of doing it. I know I kind of fumbled through that one, but I hope that you understood. All right. So this one is 10 is 16y squared minus 88y plus 121. So once again, we're looking at these, and I'm catching it now because we did it just the same as this one. So it's going to give me an opportunity again. Now I know this is a perfect square again, so I can take the square root of it. Now the square root of it is 4y. If I did 4y times 4y, I would get 16y squared. And over here we got a perfect square. You know your factors of 11. You'll know that 11 times 11 equals that, right? So this is going to be 11. That's the square root of that. Now I'm going to take down my symbol from this one. Okay, so it's 4y minus 11. This might be what our answer is. So the only thing we have to double check is just multiplying these two together. That gives us a negative 44y, and then we double it. And that gives us a negative 88y. So this checks out again. This is what we're looking for here. You can do it the long way if you'd like, but that's the simplest way to do it. All right, so then we get 9p squared minus 25. Now, this one is one you're just going to have to learn to really recognize. And these are perfect square roots of each other as well, just like we were looking here. Okay, but these are different because this doesn't have a middle term. In fact, we call this the difference of squares. But what's going to happen is our middle term is going to, I think we did it, I don't know, maybe I was thinking of 0301, but anyways, our perfect square for this, or our square root of this, is a 3p. If we had 3p times another 3p, it would give us this, right? And we know to get this, the negative 25, this can't be perfectly square rooted, but we know that a negative 5 and a positive 5 gives us that negative 25. And then what happens to our middle terms is they just cancel away. You can see that 3p times 5 gives us a 15p, and negative 5 times 3p gives us a negative 15p. So those just cancel away there in the middle. So this is going to be our difference of squares answer. Number 12. We got 16m squared minus 9n squared. Well, this is another one of those things, right? This would split into 4m and 4m. That would multiply to give us that, right? We do want to make sure that we have minus here. This doesn't work if we have a plus in between these numbers. That would throw everything off, and they wouldn't be factorable. Okay? But this is made up by a negative 3n and a positive 3n would give us that, right? And then once again, our middle terms would cancel. So another difference of squares. All right, number 13. We have 27m to the second minus 300, right? And this one's pretty this one's doable. Alright, so what we can do on this one is we can factor out, I know we can at least divide out a 3 out of both these, and I think that's all we can do. So let's just divide out a 3 out of both these and see what we get. We might be able to do more after we see what we end up with. But this is going to, 27 divided by 3 is going to be 9m squared. And then we can divide negative 300 by 3, and we get a negative 100. And now this is turned into something I can work with, right? Because once again, these are perfect squares again. I know that 3m multiplies to give me that, right? 3m times 3m gives me that 9m squared. And I know that a negative 10 and a positive 10 can give me that, right? And then once again that would go away, but we still need to put our 3 in front of these to recreate this. And that's totally factored in. Last one. Okay. We get x cubed plus 64. And anytime you see a number that's cubed and you're trying to factor it, it should just scream at you, hey, this might be the sum of cubes or the difference of cubes, right? And we got a sum going on here, which is addition, so this is probably going to be in line with our sum of cubes. Now remember that when we have a cube number plus another cube number, this is going to equal the cube root of that number, which is a, right, plus, we just take the same symbol, and then the cube root of that number, which is just b. And then we use this as our kind of our guide. We don't look back at this anymore. We look to this, and we're going to square this first term. We're going to use the opposite symbol that we used here, so this is going to be minus now. And then we multiply these two together, so we get an a times a b. And then we go to addition. We always end with addition on our cubes, sum of cubes or difference of cubes. And then we just end it with a b squared. So we just follow this format. So we're going to use this to solve this. Okay. And our first step, really, remember we took our cube root of our first term, which is just x. And then our cube root of 64. Some of your calculators can do that, but you might have to think about it. But eventually you'll realize that it's 4 times 4 times 4 equals 64. So we do plus 4 here. Okay? Now moving on. This is a squared, so we're going to be squaring our first term, so that's going to be an x squared, right? We use minus. Now we're going to multiply our two terms by each other, so we're going to get a 4x. Okay? We end with addition. And then we're going to multiply this, that last term times itself, so we're doing 4 squared, and 4 squared is equal to, that's 4 times 4, which is 16. So that's our answer there. So this is what they're looking for as far as what it factors into. Okay?